Okay. It'll be easy to remember next week because we'll be at school. Oh yeah, I'm not sure how I'll go with having to wake up early. Yeah. It's also Monday, Wednesday, so just keep that in mind because we have to change extension 2 because of the year 11 extension 1. So yeah, so it's going to be even harder to remember because it'll be different days. All right, let's actually finish this. So this is our last question. And I don't know if you remember me saying, but there was a question ages ago that I said was like the worst ever answered question. This is actually the worst. So for some reason, it's not that bad actually, but apparently this is the worst. It's like 2% of people got the last part right, even though they're all show that questions. So like this one's show that 1 mark, show that 1 mark, show that 3 marks. So it's kind of weird, but anyway. Yeah, just keep in mind it's Monday, Wednesday, 8 o'clock. I'll be at school, but I only go to school for the extension class because it's kind of my only class. Yes, unless you want to come to advanced. But if you want to come to advanced, so on Monday we have a 4th period. You have to leave and then come back because you're not allowed to stay at school. So, but that's completely optional. You don't have to come to that, obviously. So yeah, you'd come at 8 and then leave at 9, essentially. But you're more than welcome to come to advance, but that just means you've got to leave and then come back. But that's up to you. And then Wednesday we have advanced straight after. So I have advanced first period. So you're more than welcome to stay if you wanted, but you don't have to at all. But Chloe would probably stay. That's if Chloe came to extension in the first place. But, yeah. So I'll let you think about that. I wish you could come for extension 2, but Queen was not allowed because he's in year 11 technically. So it'd be kind of unfair if you came to school and he didn't. Oh well. Yeah. I'm getting my second shot on Monday. Oh, okay. Okay. So you'll be there is it like in the afternoon or something? That's exciting. Hopefully you don't get sick. I didn't get sick on mine, but a lot of people get sick on theirs. You'll be at school. Okay. Yeah, it kind of sucks because the start of extension 2, I'm just gonna have to record videos, but that's okay. In the afternoon. Yeah. Okay. Cool. Cool. Okay. Let's have a look at this box. So I've got a box contains N red balls and N blue balls, and then I choose R of them. And so obviously R is less than N. And explain why the possible color combinations are +1. So I don't know. This is straightforward if you don't think of it in terms of combinatorics. Like you look at that and you think, oh, I've got to come up with some combinatoric expression. But I think you'd be better prepared for this question if you knew nothing about extension 1. So it's only 1 mark, so you're just going to make it says explain, so you've got to make some sort of a justification. So this is what the solution kind of goes through, but it makes heaps of sense. So you just go through each case. So the combination and so just the selection of R is made. Yeah, the number of possible combinations. So let's suppose I'm going through each of the cases for R. So how many balls do I actually select? So I could select none. That's kind of pointless. I could select 1. So I could select 1 ball out of the bag or whatever it's in. Does it even say? No, it's just a box. And then if you think about what could possibly happen, only 2 things can happen. I could either have a red one or a blue one, and that's it. And you'll notice that if this follows the rule R+1, because I've selected 1 ball and there's 2 possible combinations, 1 + 1. And then if you just go through the next one, so the combination of, instead, let's suppose I pick out 2 of them, what are the sort of things that can happen? Well, I could have two blue ones, I could have two red ones, or I could have a red and a blue. And notice that it doesn't say like an ordered pair, it just says a selection. So that's three things. And again, 2 plus 1 is 3, so this is following the rule so far. Combination of 3, 4, probably put an S on there. Okay, so this one's a little bit more tedious, but I guess the way you could think of it is like, let's suppose I get 3 blue ones, and then I'll do what you do in the binomial theorem and start dropping 1 and adding 1. So I'll get 2 blue, 1 red, and then 1 blue, 2 red, and then 3 red. So they're all the possible combinations. There's 4 of them, and again, 3 plus 1 is 4, and it's still following my rule. We can go one step further if we want to continue this, but I think you can see that it's not going to really change. So 3 blue, 1 red, 2 blue, 2 red, 1 blue, 3 red, and 4 red, and that's 5 things. So at this point, it's kind of like a proof by 2 blue, 1 red. So at this point, it's kind of like a proof by exhaustion, but obviously we can't just keep going, so you just kind of conclude and be like, combination of R balls is R plus 1, and that would kind of be your proof. It doesn't strictly say prove, it just says explain. So does the second one, but then the last one says show that. So I think that show that's a little bit different to explain. Explain's kind of like, yeah, like explain, I guess. Okay, so that's the first one. Second one. I think the first two are actually pretty easy. I've got another box. It still has N, but it's white ones instead, and they're labeled 1 to N, and then you select N minus R of them. Explain why the different selections is that. So if you do think of this in terms of combinatorics, simply because my answer is a combination, just think of it purely as I have a number of these balls in a box, and I'm selecting a number of them. It's literally just, so the selections, there's N of them, and I'm choosing N minus R of them, and somehow I have to show that this is equal to this. And I think that's kind of obvious just based on the theory of combinatorics and like Pascal's triangle and stuff. This is something you would have probably proven back at the start of year 11. And it's kind of just like, here's Pascal's triangle. It's just that these two values are the same and these two values are the same. And enough of a justification would be to say something like, it's called the symmetry product, the symmetry, what is the word I'm looking for? Symmetry identity. The symmetry identity. But it's not that hard to prove. Like if you just write n factorial on, and then you just go n minus r factorial, factorial. That's the basic one if that was r, but you just replace every r you see with n minus r. So if that was n minus r, then the n's going to cancel, and you have n minus r here, and it ends up being this anyway. So that's really easy to prove if you wanted to go the extra mile, but I think it's enough to just say that it's the symmetry identity, because that's probably something you would have proven at some stage before anyway. Okay, and the very last part is a slight stitch up, because it actually relies on, like this is question 7C in the HSC. Question 7B actually proves a different property of this, so it's a little bit of a stitch up for us in that this is just an isolated question. Also, I don't know if you remember, but that weird advanced question that we did, that we were like, that's extension 2, but then it ended up being advanced, that was also in 2010. So I feel like the people in 2010 got stitched up a little bit with their tests. Yeah, so like this is, I think this is the last question, or maybe it's not, that's only question 7. Anyway, it's one of the last questions in the extension 1 exam, and that weird advanced question, I forget what it was about. No, that's not going to be on here. Actually, so it would be. remember that weird one? It was like, yeah, this one, this advanced one. That was, yeah, see, 2010, that advanced. Anyway, so those people got stitched up a lot. Okay. I think the key with this part is that it's two show that questions leading up to a bigger show that question. And it's just that there's n red balls, n blue balls, n white balls, and it's the same n, like we're using the same value for n. It's not just like a new. It says the n red balls and the. So I think that's the key word in knowing that like this isn't just a completely separate independent question. They're all placed in one box, and then they choose n of them. So there's n of each color, and then they choose n, not necessarily from the same color. And then it says show this, use this identity, and then show that the number of selections is this. So we've already, it's strange because we've already come up with two expressions that talk about the red and the blue ones, and then a separate one that talks about the white ones. So the first expression talks about red and blue, and that the possible selections being r plus 1, given that I select r of them. And then the next one shows that we have n white ones, and then this is the selection, so nr. But I guess the hardest part is identifying that if I were to select, so this one wants me to select n, so I want to select n of them, but the last question I selected r of them, and then the question after that I selected n minus r, so then n plus, r plus n minus r is n. So in other words, I'm performing both of these selections. I'm performing the selection from I, and I'm performing the selection from II. So kind of like from I selected R, and then from I selected n minus R. So then in total, that should be in total, I selected R plus n minus R, which equals n, which is what I want to select. And so then my selection of n can just be me selecting each of these separately, which is kind of like just going, oh, well, here's the number of selections for this one, here's the number of selections for this one. So therefore, the number of selections is r plus 1 and r. I hope that kind of makes sense. And the reason it's times is because the only way I can think of it is like using your tree diagram kind of thing, and there's multiple steps. The first step is selecting the amount of red and blue. So this is like the red slash blue, and that's r plus 1. And then your next selection is the white ones, which is, and choose r. And when you move on the same branch, you multiply. So that's my justification for it being multiplication. Now, when I've got this, the next thing I need to do is try and make it look like that thing over here. So one thing I guess you can do is just recognize that this thing over here is a set of brackets. That's r times nr plus 1 times nr. And now that we have these n choose r's with a r in the front, and my property here is, I'll just write the property. So n minus 1 equals, that's a terrible sigma. K. Also, they use K's, which is a little bit frustrating because we're using R's. So you notice that this looks pretty much exactly the same as this, except using R's. So I can make a direct substitution of this to here, but number of selections. So the next thing is the number of selections. This is just in general. If I wanted to find the total number of selections, then you could just use the fact that I'm going to have to sum something because it's a show that question. But the reason I'm using a sum is because if you look at part 2, it says the balls are labeled from 1 to n. So I can use a sum because obviously they're integer values because there's a natural number of them, which that should make sense. So the total number of selections, because this property here, this, let me circle it, this property here is just kind of looking at one case. So let's suppose I had like 20 balls and I chose 5 of them. But if I wanted to know how many total selections, then I need to make a sum of every single possible n and r value. So I'm going to sum. We haven't really, this is also a stitch up because we haven't really worked with sums before, but they do work like brackets. Like if I take the sum of all of this, it's the same as taking the sum of this and the sum of this. I don't know why I wrote an E there. So I'll take the sum over this thing, and I'll take the sum of this thing, and I'm going to go from r, because I'm starting at r, when r equals, do I want to start with 0? No, because I never selected 0. So when r is 1, and I go up to n, so I select r amount of balls, and I go up to selecting the total amount of balls that there are. I feel like there's a bit of a stitch-up question because there's a lot of stuff we probably don't really know, but it's kind of interesting anyway. It's kind of interesting to see why it's considered to be so hard, I guess. Okay, so then this thing on the left is literally this, so I can just write this essentially. This thing's a little bit less obvious. It's also slightly stitch up because, like I said, the last part, so the 7b kind of dealt with this case, but yeah, I'm not going to really have an explanation as to how this goes into what it's about to go into, but you can kind of think of it like, I'm just working over here. There was a 1 here, and so then this would be the 1 that I'm looking at, and the k value here is kind of reflective of this, like k goes from 1 to n. So I don't really have a justification as to how this is going to work, but essentially it's just 1, 2, and then instead of like over here, that looks terrible, it looks like 12. You're at 1 times 2. Instead of it being n minus 1, because I'm not multiplying by values leading up to n on this side, because I don't have an n here. It's actually going to be 1 less power of 2, so that it'll be that. But that's better explained in a previous question, so that's not something that I'd expect anyone to be able to do just like off the top of their head. We're just working on this question. So, like I said, this is a bit of a stitch-up question, so I apologize. Anyway, so now we just need to make it look like that thing on the bottom, the n plus 2. So one thing I can do is make these powers look the same. So the way I can do that is just by going to n minus 2. I'll just go 2 times 2 n minus 1. So then when I multiply these two, I get this. So that one's just kind of annoying, so go away. And then I can factorize with 2n minus 1 out. So 2n minus 1. And I'm just left with n plus 2. And then I can draw my little whatever, my poo emoji or whatever you used to draw. But yeah, that's a little bit of a stitch-up question, but I feel like not knowing any of the other parts, you'd still be able to get 1, 2, 3, 4, 5, 4 out of 5 marks, probably. But yeah, that's it. We've done all 23 of the hardest extension 1 questions possible. And I was thinking, because we have 2 lessons in class, what do you reckon about doing some of those, do you remember the vector geometry stuff? The ones where it was like, they give you like an octagon or something, and it was like, prove that the sum of them equal 0, or like this plus this equal, I don't know, like I can't even remember what they were. Yeah, you drew it on the board, I swear. I'd have a picture of it somewhere. Yeah, what do you reckon about doing that? Because I found them kind of fun, and you said you hadn't done vectors in a while. We could just work through some of those in class, like from the Cambridge textbook or something. We don't have to. That's just a suggestion. But other than that, I don't really have anything else that I could find. I could find some hard questions and go through those. Or you could just sit in silence and do a test, but that's kind of boring. I don't know, unless you want to do that for one lesson and then geometry for another lesson. But I'll let you think about it because I don't mind what we do. I'm going to do Jeopardy with advanced. So if you wanted to come in for the advanced lessons, that's probably what we're going to be doing. I'm sure someone would want you on their team, because I don't think many people from that class have done a lot over lockdown. So anyway, if you don't have any more questions, then I guess I'll see you Monday. Do you think Chloe will even turn up? It's a great question. Yeah, that's a great question. So I've got, what is it? Well, she should at least come period 4. I, yeah, look, I don't know. I really don't know. I hope I wasn't. I hope she knows. Like I swear I posted. Yeah, so I said Monday, Wednesday. I hope she's seen that. I'll post it again, but I tried to get it on your timetables, but I don't think it is. I might have to turn up to school for a class that's not on my timetable. Um, yeah, I asked Mr. Reese, and he didn't get back to me. I'll ask him again, but I'll ask him if he can come to the advanced lessons. You should be able to. You're technically, or you won't be able to the week after. Oh, but no one will be at school the week after. God, it's so confusing. It's a week. Yeah, everyone will be. Oh, so you don't. Look, I don't know. I think it's fine Wednesday because Wednesday we've got first period, so you could just kind of stay. Um, I'll ask. I'll ask if you want. I don't know the answer to that, but I'll ask and I'll let you know. And I'll also post on here again saying that we're going to be here Monday, Wednesday, just to remind Chloe. But yeah, I'll be there from like before 8. So, but if you do have any other suggestions what you want to do, otherwise I'll just find some geometry questions. When do the year 12 classes end? In 2 weeks. So next week's only year 12, and then the week after is everyone and year 12, and then no year 12. So yeah. So there'll be 1 week where you're at school with me every morning except Friday, and then it'll go back to Tuesday, Thursday. Unless they change it again, of course, but they've changed it like 5 times now. Yeah, because it's confusing because you're kind of in year 12 and kind of in year 11. Yeah, I think that makes sense. All right. Well, if we're good, I will see you on Monday in person. And don't forget to bring a mask because we have to wear masks. Um, okay. Goodbye.